Morning, everyone. Good morning, all of you. A very good morning to all of you. Okay, so very good morning to everyone. Yes. So yesterday we have been discussed about the different type of failures, and yesterday whole we have been discussed about the type of failures and type of slopes. And now, as we know, there are different type of slopes. We need to analyze those slopes variously, means differently. See, what is the meaning of a stability analysis? I told you to check the safety factor, whether it is going to be safe or not. So we need to find out the factor of safety. So as you know, there are two different type of failures, and the main one is going to be translational and other one is going to be rotation failure. Translation failure occurs in the case of infinite slopes, whereas rotation failure occurs in the case of the finite slopes. And mostly the commonly seen that rotational failure is going to be toe failure. When I greater than 50 degrees, then the toe failure is going to happen. And for analysis, we are going to take the slip surface should be passing through the toe and having center O. So now let's see what about the analysis one by one. First we go for the infinite slopes and then we go for the finite slopes. So now if you observe, let's see first one. Stability analysis of infinite slopes. Stability analysis of infinite slopes. First of all, we are going to assume some things. The assumptions are soil is homogeneous. While we are going to do some analysis, always we have some assumptions. So soil is homogeneous, and next one is going to be look I told you the type of failure in the infinite slopes is a translational failure. How does a translation failure? Failure is it rotation or planar? Planar and parallel to slope surface. Parallel to slope surface. Failure is planar and parallel to slope surface. Now, what we are going to learn from this side. So now let's draw an infinite slope. As I have already shown you, this is nothing but an infinite slope partner. And you know the soil mass will go inside and then move downwards and then outside. So this failure, this is known as a translational failure. Now you see, whatever this is nothing but a translation failure, and this is going to be planar to the slope surface. So now let's draw an infinite slope. Let's take this as an infinite slope. Let's take this as an infinite slope. So whatever this is nothing but a slope surface. Whatever this is nothing but the slope surface. Slope surface. Now, what is the meaning of the translation failure, sir? So the meaning of the translation failure is first the failure will travel inside of the soil mass up to the weakest plane, and then the failure plane is going to be passes. So the failure is going to be parallel to the slope surface. Yes. Whatever this failure, this failure is known as a translational failure. So this is known as translational failure. And now let's see, if I say the angle made by the slope surface is I, then as the failure is planar and parallel to the slope surface, the angle made by the failure plane is also going to be I. So this is known as a failure plane or slip surface. So now, how to do the analysis? Let's see. Let me take an element over here. So let me take an element over here. Whatever the failure surface are, if it is going to be failure plane, let me take an element over here. This is an infinite slope. So now, if I take an element having width as B, the width of the element is going to be B. If the width of the element is going to be B, now you see, you observe you know, this angle is also going to be, whatever this angle is going to be, this angle is going to be I. Yes. If this is going to be B, then what about this value? B cos I. Yes. So this side is going to be B now. Whatever this value is going to be B. So if this is going to be B, if this value is going to be B, then the value of this value is going to be whatever the dotted line I represent is going to be B cos I. Sir, why you are finding all these things, sir? So now let's see why I'm going to find out all these things. Okay. So what is the factor of safety? Please tell me first of all. What is the factor of safety? Factor of safety means a shear strength by shear stress. Yes or no? See, you see what is the factor of safety I have represented over here? Type of failures are shear strength by shear stress. So what is the shear strength, sir? C plus sigma into tan phi by tau. C plus sigma into tan phi by tau. Now, everybody, I can conduct the laboratory test, triaxial shear test or UCS test, whatever the test, I can find out the C comma phi. I can find out the C comma phi by conducting the laboratory test. So if you know the C and phi gamma of the soil mass, you know C, phi, gamma. Gamma means unit weight of the soil, and you know the slope angle as I. Now our main point revolves around this sigma and this tau. So if I can find out the normal stress and shear stress, I can find out the factor of safety. I can find out the factor of safety. Does my voice is clear? Please let me know. Some of the students are asking, does my voice is clear? Okay, okay, fine. Yeah. So now you see, if I know the sigma and tau, then we can find out the factor of safety. Sir, you know that on any plane, there is a normal stress and there is a shear stress, and opposing is nothing but the shear stress. So how to find out this normal stress and shear stress? Let's see how to find out that one. You see, this is a small element of width B, and definitely this will be having a a weight component like this. Yes. So whatever the weight, this is going to be W. Let's find out the weight. So first of all, so for this element A, B, C, D, volume of element A, B, C, D is equals to area of A, B, C, D into 1. Sir, why is the 1, sir? Perpendicular to the board, sir. Perpendicular to the board or plane. See, what we are seeing is a 2-dimensional, right? Volume means 3-dimensional. So as we cannot see the length of this slope, so we take it as 1. What is the area of ABCD, sir? Let's take the element is at a depth of Z. The element is at a depth of Z. So now, what is the area of this element, sir? You see, if this is B cos I, then here also this is going to be B cos I, which means this portion and this portion both are same or not. So now, what is the area of this element is going to be B cos I into Z into 1. B cos IC. I hope you understood. Or you see what is this depth? Z. What is this depth? Z. So if this is going to be Z, this is also going to be Z. Now, my dear students, you observe, if this is B cos I, what is here? B cos I. I am adding whatever this portion, I am adding this portion over here. So this portion and this portion both are going to be same. So whatever this portion over here, this portion both are going to be same. Then what is the area of this element? You please tell me. Depth is going to be Z and width is going to be B cos I. So the area of this element is going to be B cos I into, sorry, B cos I into Z. So okay. So once we know the volume, then weight of soil in AB, CD. So whatever the weight is nothing but density into volume. So what is the density? Gamma into volume, gamma Z into B cos I. So now, my dear students, whatever the weight I am going to add over here, what is this weight, please? This weight is going to be gamma Z into B cos I. Now, everybody, does this weight is going to be perpendicular to the plane? See, this is the plane, right? This is the plane. So now let's take that plane again outside. Yes, this is the plane. And this is the weight, W. Now, this is weight W. So now I took the plane again, and this plane is going to be make an angle. You know that the angle made is going to be I. Look, as the weight is going to be not either perpendicular to the plane or parallel to the plane, I can resolve this into two components. Now you see, what is meant by normal stress? Normal stress means stress perpendicular to the plane, and shear stress means stress along the plane. Yes or no? So now, my dear student, here the weight is not going to be perpendicular plane. You see, this is the weight. Is it perpendicular to this plane? No. Is this parallel to the plane? No. Now, can we resolve this into two components, right? Yes or no? So if I can resolve this into components, now you see, I can resolve this into two components. One is perpendicular to the plane, other one is going to be parallel to the plane. One is perpendicular to the plane, other one is going to be parallel to the plane. How, sir? You see, this is perpendicular plane N, and whatever this is nothing but parallel to the plane T. Perpendicular plane N, parallel to the plane T. So now, I hope you understood. This weight is going to be resolved into two components, and one is going to be normal component, other one is going to be tangential component. So now let's take this one again. If this is a weight, now that normal component will pass us like this. And the shear component will pass us like this, T. So let's take out that element again. This is going to be normal component, and here it is going to be shear component. whatever there is nothing but the weight component, which is going to be vertical, and then we are going to resolve into two components. One is a perpendicular to the plane, other one is parallel to the plane. So what is this? This is going to be weight, and this is going to be normal component, and this is going to be tangential component. You observe here the tangential component means shear force. I told you clearly, if a force acts perpendicular to the plane, normal force. If a force acts along the plane, that is going to be shear force. So now, if you observe, as you know, this force acts along the plane. Whatever this angle, this is nothing but I. Yes or no? Because what is the slope angle over here? I. So this is N and this is going to be I. Then if this is I, what about this value? 90 minus I. Then this is going to be I. So if this value is going to be I, then this value is also going to be I. Now you please tell me, whatever the component next to the angle, if this is I, this is weight, whatever the component next to the angle, this is going to be W cos I, and this is going to be W sin I. So see, what I am doing is, at first I am finding the weight of the element, then I am resolving the weight into two components. One is normal to the plane, other one is going to be tangential to the plane. So now from this normal force, N is equals to W cos I. What is mean by W cos I? Gamma Z into B cos square I. What is tangential force? W sin I. What is W? Gamma Z B cos I. So gamma Z B cos I sin I. Sir, why you are finding all these things, sir? Why you are finding the normal component and shear component, sir? Sir, my point is to find out the factor of safety. In order to find out the factor of safety, you need to find out the normal stress and shear stress. Now, my dear students, everything is there. So now I have normal component with me. Now I have normal component with me as N and shear component. Now you tell me, what is normal stress? Normal stress, sigma is equals to normal force by cross section area. So what is the normal force? N. And now come to over here. What is the area over here? You please tell me, Nana. You see, what is this area? Now this is going to be B. What is the area? B. Because the force is going to be, if this is a plane, this is going to be the normal force, right? Whatever this normal force, now the area is going to be this area you have to lay. Yes. And what is this area? What is this area? This is going to be B, and perpendicular to the board is going to be 1. So now we need to look over the area as B into 1. So come on, my dears. So what is the N value? Gamma Z B cos square I by B into 1. So now after finding, sigma is equals to gamma Z cos square I. Gamma Z cos square I. And similarly, tau is equals to tangential force by surface area. See, whatever the cross section area, you see, this is whatever the cross section area for the normal force will be the surface area for the shear force. Yes or no? Whatever the cross section area for the normal force, this is a normal force. This is a normal force. So for this normal force, this is a cross section area. And if it is a shear force, for the shear force, the same thing is going to be the shear area or not. So now the plane is going to be having some width B. This is a width B. Now force is acting here. So normal force by B into perpendicular board, you don't know that, into 1. So now if I do this one, then gamma Z cos I sin I. So ultimately, my dear, I got to know that sigma and tau. So let me represent that in the plane. whatever the normal stress, whatever the normal stress means perpendicular plane, this is going to be sigma, which is going to be gamma z cos square I, and shear stress gamma z cos I sin I, and now we need to find out the shear strength. So now ultimately the factor of safety F is equals to C plus, what is sigma please? What is sigma? Gamma z. Just now see the formula C plus sigma tan phi, right? Sigma gamma z cos square I tan phi by tau gamma z cos I sin I. And mind it, this is very important formula. C plus gamma z cos square I tan phi by gamma z cos I sin I. Look, this you must have to remember. You must have to remember, and mostly they ask conditions of this formula. I can say you the equation directly without saying the derivation also, but if you go with this, then the remaining problems, there are some problems where you require more basics, wherever you go, wherever the weight of the soil is there, wherever the weight of the soil is there, then you have to resolve. See, first what I am doing over here, first I am finding the weight of the soil mass, and then I am resolving the weight into two components. One is normal component N, and other one is going to be tangential component T. So should I have to write N as normal component? No, right? Normal N, tangential T. Once you know the normal component, then you can find out the normal stress and shear stress. So this is how you are going to find out the normal stress and shear stress based upon the weight. So now ultimately this equation, this is very important relation. We'll see the problems based upon this. So I hope you understood the equation. Plus please you go through once. Now I'm going to discuss about the conditions. So first we find out the volume, and we find out the volume as area of ABCD, whatever this is, this volume, both are going to be same. So Z B cos I, and if you add this portion over here, then the area Z into B cos I. Okay, I hope. So now let's see the conditions. And these conditions are very important for cohesionless soils. For cohesionless soils, what is the meaning of cohesionless soil? The meaning of cohesionless soil means C is equals to 0. So when the cohesionless soils means when C is equals to 0, now in this A, dry condition, in this A, dry condition. What is the meaning of dry condition over here? The meaning of dry condition is when there is no water at all. So first, in the case of the dry condition, now my dear students, come on, you please tell me what is the factor of safety over here. So C plus gamma z cos square I tan phi by gamma z cos I, sin I. As I told you now, just now, C is equals to 0. When C 0, then gamma z will get cancelled. One cos will get cancelled. Now, if I take this cos to the denominator, then sin I by cos I. What is this sin I by cos I? You see, C0. When C0, then gamma z gone, right? If I remove the C, then gamma z gone. One cos. The remaining numerator is cos, denominator is sin. You send the cos to the denominator, then sin by cos I, which is nothing but tan I. Finally, the factor of safety is equals to tan phi by tan I. Tan phi by tan I. And now, what is this tan phi by tan I? This is the factor of safety for a cohesionless soil mass. Sorry. For a cohesionless soil mass. This is the factor of safety for a cohesionless soil mass. Yes. So whenever in the case of the dry condition, I just said C0. So if I keep C0, the factor of safety is going to be tan phi by tan I. Mind it, this is very, very important conditions. So based upon these conditions, only a lot of previous gate questions have been asked, and even in ESE also. But in ESE, not much questions have been appeared from this chapter. So now the meaning of this I is, please observe. If I less than 5, then factor of safety is going to be greater than 1, safe slope. If I equals to 5, critical slope. And if I greater than 5, unsafe. Yes. So now, my dear students, what is the maximum angle, slope angle? What is the maximum slope angle that you can provide without any failure is I is equals to 5. Yes or no? So that is the reason why in the case of the sandy soils, means cohesionless soil means a sandy soil or not? Yes. The natural slope is going to be maximum of 5. The natural slope is going to be maximum of 5. So now if I draw a, see, observe, you know this is sigma and you know this is going to be tau. And you know the failure envelope for the cohesionless soils, right? For the cohesionless soils, if C is equals to 0, then this is going to be the failure envelope. It is going to be the failure envelope making an angle phi. This is a failure envelope. Now keep that in your mind. Now our slope is going to be I. Yes or no? As long as if I less than 5, as long as I less than 5, you see now what is this value? This is going to be I, which is less than 5. Then this is going to be safe slope. So keep that in your mind while we are going to provide the infinite slopes. In the case of the infinite slopes, whatever the slope is there, we are discussing, you see, this slope, if this slope is going to be less than or equals to angle of internal friction of this soil mass, then the infinite slope is going to be safe. That is the meaning. Ultimately, we require some conclusion or not. The conclusion is, if this slope angle I, where you know that I means slope angle, if the slope angle I is less than 5, then it is going to be safe. Sir, if I provide a slope, if this is a slope, and now you see here, this is I, which is greater than 5, and I can say this is an unsafe slope. So keep that in your mind. In the case of the cohesionless soil, I am discussing about the cohesionless soil, Nana. So in the case of the cohesionless soil, what is the factor of safety? factor of safety is equals to tan phi by tan I. You see, this complex equation has been reduced to very simple equation by just a small modification taking C is equals to 0. Sir, in the case of C5 soil, then this is the equation. Sir, in the case of cohesive soil, sir, in cohesive soil what happens? Phi 0. When phi 0, then this term after whatever the term after place, it will be gone. Then what is the factor of safety? C by gamma z cos I sin I. So I hope you understood. And next, coming to B, submerged condition. Submerged condition. So what is meant by this submerged condition, sir? What is meant by submerged condition, sir? See, if the entire slope is under, water, if the entire slope is under water, completely submerged, then as soil is slope is completely submerged, then use gamma dash. So now you see sigma becomes sigma dash, gamma dash into cos square I, and tau becomes gamma dash cos I sin I. Cos I sin I. So now, my dear students, you see, this is the sigma and this is a gamma. This is sigma and this is going to be tau. Yes or no? So in the case of the sigma and the tau, gamma z cos square I, gamma z cos I sin I. And as it is completely submerged, now I am going to take instead of gamma, I am going to take it as gamma dash, as it is completely submerged. Now what is the factor of safety? The factor of safety is equals to C dash plus gamma dash cos square I tan phi dash by gamma z cos I sin I. So now when C is equals to 0, what is the factor of safety then? Come on, please tell me, everybody. When C0, you tell me please. C0, gamma dash into Z will get cancelled. Gamma dash into Z will get cancelled. Cos gets cancelled. Then finally, whatever the value is going to be tan phi dash by tan I. The same equation you are going to end up. But instead of this equation, you see, in this equation, instead of the C, I am taking C dash because it's going to be completely submerged under water. So as it is completely submerged under water, you know that whenever we take the submergence, are we going to take effective stress or total stress? Effective stress. So now, let's come to the C. Study C pays parallel to slope. See, this is very, very important. You please observe. Study C pays parallel to the slope. So now let's draw the same figure. Let's go to this one. Okay, instead of that, I'll draw separately. Okay, fine. Yeah, you know, this is a slope surface and this angle is I, and you know, this is going to be the slip surface and this angle is going to be I. And from this, by knowing the weight of the soil mass, we have found out the normal stress acting over here, whatever the normal stress acting over here as a gamma z cos square I. I have just found it out. I just found it out. You just have a look. So I have found out the normal stress. See, stress means it is going to be acting along this plane, right? That's it. At this point, this is the stress. This is the point. This is the stress. Now, whatever the shear stress is going to be gamma z cos I sin I. I hope you know these conditions. Now, apart from that, you know the depth of the soil element is going to be Z. So everybody, you have understood these conditions. I have already shown the sigma and tau. Now, what is going to be happen? See, if it is going to be seepace, if there is a water table parallel to the slope surface, if there is a water table, so now if there is a water table which is going to be parallel to the slope surface, mind it. See, if this is going to be the water table, definitely the flow will take place from the higher level to the lower level. See, mind it. Now you tell me, do you think the both water levels are going to be at the same height? Do you think they are like looking like this? They are looking like this. So here 1 and here is going to be 2. Flow will be taking place from 1 and 2 are not. See, when the water levels are at same level, then there is no flow. But if the water levels are at different levels, then there is a flow known as a seepace. So now, due to this seepace, first of all, soil is going to be, you know that if the water table is there, gamma becomes gamma sine. So now, what I do is, what about this? Nothing but gamma sat into z cos square I. And this is also going to be gamma sat into z cos I sin I. Now you tell me, so look, due to steady seepace, so an excess pore water pressure is going to be developed at the failure plane. Now you tell me, see the failure plane, this is going to be, now before going to this one, I want to ask one question. Just have a look please. If this plane was a horizontal, what is the meaning of plane is going to be horizontal please? What is the meaning of plane horizontal? I is equals to 0. Yes or no? Just simply introduce I equals to 0 in sigma. If this is going to be horizontal, if the slip surface is horizontal, then I0. When I0, then cos 0, 1. Then what is the vertical stress? Gamma sat into z. Yes or no? Yes or no? See, you know that if this is going to be horizontal, if this is the water table, you know the vertical stress is going to be gamma sat into z. And what about the pore water pressure is nothing but, if this is the water table, piezometer will rise up to here, then gamma W into z. So this is the pore water pressure and this is going to be the total stress. Yes. Now my dear student, but does the plane is a horizontal or inclined? inclined. As it becomes inclined, now this is going to be cos square I. Similarly, here also cos square I will come or not? Now you see, as gamma W into Z cos square I. So you see, along this, there is a pore water pressure, and this pore water pressure is gamma W into HP. And sir, water table is going to be here, sir. So that water table, as it is HP, now I can write as gamma W into Z into cos square I. Sir, how it came, sir? The same way how it came, how I have explained. How I have explained with the normal stress. Just go back once again. With the normal stress, how I have explained, by taking the weight of soil, right? Yes, but in the case of the pore water pressure, you have to take the weight of water. You have to take weight of water. So pore water pressure is due to water, right? So now the same way, due to steady sea pace, whatever this direction, you know, generally if it is a horizontal plane, gamma sat into Z. Gamma sat into Z. I hope you understood. Gamma sat into Z. When the plane is going to be horizontal, that is going to be gamma sat into Z. And if pore water pressure is going to be gamma W into HP, as water table up to water ground level, then gamma W into Z. But as they are inclined with I, then there is a one coefficient cos square I. This is also going to be cos square I. So now, my dear students, what is the net? How many forces are acting over here? Please tell me. How many forces are acting over here? In the vertical direction is perpendicular to the plane. Two forces are sigma and U. Then now from this, sigma dash is equals to sigma minus U, which means gamma sat into Z cos square I minus gamma W into Z cos square I, which simply gives gamma dash into Z cos square I. Sir, whereas tau, sir, tau is simple, gamma sat into Z into cos I sin I. So I hope you understood this condition over here. So first of all, as it is a water table, I took the saturated weights, and due to steady sea pace, pore pressure is developed at the failure plane as gamma W into Z cos square I. How it came is simply as previous one only. I'm not going to define. So I'm not going to derive the equation for that also. So now what is the factor of safety? C plus simply I'm taking as a C or C dash also. It depends upon whatever the factors you are going to take. So C plus gamma dash into Z cos square I tan phi by gamma sat into Z cos I sin I. Cos I sin I. Now this is the equation. This is the equation. See, after all this one, I want you people to understand one thing. When there is a sea pace, now my dear students, you please look over this point. This point is very important. When there is a steady sea pace, you see in the numerator, I am taking as a gamma dash. Keep that in your mind. In the numerator, I am taking the effective stress. Understood? I am taking the effective stress. And in the denominator, I am taking the gamma sat. Because in the numerator, there is a normal stress and there is an upward pore water pressure. So gamma becomes gamma dash. But in the lateral direction, you see this is going to be the shear stress R naught. That is going to be gamma sat only. So my dear students, please, at the end, the conclusion for you to remember is, when I ask you a steady sea pace condition, keep that in your mind. In the numerator, you have to take the effective stress, and in the denominator, shear stress, which is going to be total stress. gamma sat total, gamma dash effective. So now once I get this equation, when C0 means if the soil is going to be cohesionless, what is the factor of safety now? Come on, tell me. If C is equals to 0, then now these are not going to be gets cancelled. Gamma dash by gamma sat into z to z cancel. One cos gets cancelled, and tan phi by tan I. If you take phi dash, then tan phi dash by tan I. So this is the final equation. This is the final equation. You please observe, compare to the submerged condition. This is the submerged condition, and this is going to be the seepage condition. Sir, when does this steady seepage condition occurs, sir? In the case of the rainy season, sir. In the case of the rainy season. So now you tell me, you please observe, what is the factor of safety over here? Gamma dash by gamma sat into tan phi dash by tan I. And what about here? Tan phi dash by tan I only. Now, compare it to submerged condition. If there is a steady seepage, does the factor of safety is going to be decreases or increases? Decreases. Why, sir? Sir, what is this numerator, sir? Gamma dash. And you know gamma dash is nothing but gamma sat minus gamma W. So gamma sat minus gamma W, gamma dash by gamma sat. See, if I take gamma sat as 20, if I take gamma sat as 20, 20 minus 10, what is gamma dash? 10. 10 by 20, which is going to be almost half R naught. Yes or no? So now, can I say, compare to submerged condition, compare to submerged condition, if there is a seepage comes into the existence, compare to the submerged condition, if there is seepage comes into the existence, the factor of safety is going to be reduced by gamma dash by gamma sat, which means almost 50%. If I give you gamma sat as a 20, then what is gamma dash? 20 minus 10, which is going to be 10 by 20 as a 0.5. 0.5 into tan phi dash by tan I. And what is this? Tan phi dash by tan I. So now ultimately, here I am going to take this condition as note due to steady seepage, due to steady seepage, what happens is the factor of safety reduces by almost 50%. So slopes infinite slopes fails mainly by seepage condition. And you know that landslides, whatever the landslides I am showing you, this is a landslide, right? Landslides occurs mostly in rainy season due to seepage. Landslides occurs mostly in rainy season due to seepage. Okay, so now you see, so which one is going to be more vulnerable condition in the case of the infinite slopes? I have been discussed about the three conditions. So the three conditions are, one is a dry condition, so second one is submerged condition, and third one is going to be steady seep is parallel to the slope. Yes. See, I can explain this one in the various ways also. Sir, if gamma sat value is 60, then it reduces by 80%. Gamma sat value is 60, just think. Practically there are some unit weights for the soil mass. You please go through. So far we have done a lot of questions, right? Wherever you see the saturated unit weight, its range is around 19 kilonewton per meter cube to 21 kilonewton per meter cube. You please go through that. 60 kilonewton per meter cube is not going to be happen. So that's the reason why almost 50%. I did not say 50% also. It's almost 50%. Sir, how the submerged and seepage is going to be different, sir? Submerged means no flow. Submerged means no flow, whereas in the case of the seepage, there is a flow. Okay, fine. Very good questions, sir. Where we see submerged slope and why to do analysis of such a slopes? Submerged slopes are going to be present in the case of the tectonic areas. You see, my dear student, these are hills, and you see the flow. I hope you might saw the Discovery Channel and all those things. Can you please tell me what is the slope? Can you please tell me what is the slope? Now this slope is going to be submerged slope. Now the slope is going to be submerged slope. It may be river or ocean or canals. So canals means there you are going to see the man-made slopes, but these are the naturally forming. Oceans or rivers, they are going to be naturally forming. So you can see whatever the slope is nothing but the submerged slope. So in the case of the submerged slope, the entire soil is under the submergence. So you have to take gamma dash. And whenever there is a rainfall, then this is going to be seepage condition. See, apart from this, then there is going to be the seepage condition. If you want me to explain in a different way also, I'll be explaining you. Some of the students are asking me. Haven't you ever seen that there is a river in between mountains or hills? Haven't you seen that? Or water bodies? Yes, there is. But the difference, the distance between these slopes is going to be more. So that the width of the river is going to be more. So you can see a lot of hills, Papikondlu hills, and I mean, as I said, you are very poor in the geography. So my dear students who have given some good knowledge about geography yesterday, so you know it very well. And yes, Ganga River in Uttarakhand, Papikondalu. Okay, so now I will explain you one more in the note point. For better understanding, submerged slope, study seepage. Submerged slope, study seepage. Listen. Just now I have shown you, if there is a water table like this, if there is a water table like this, then you can see this is entirely completely submerged under water. This is a slope surface. So now you tell me, as it is completely submerged under water, the vertical stress sigma dash is gamma dash into z cos square I, and here it is going to be tau is also gamma dash into z cos square I. Yes or no? So this is what I mentioned. This is what I mentioned. Now, what is the difference in the steady seepage? You please observe. Now, in the case of the steady seepage, water table is going to be parallel to the slope surface or not. Okay. First, sir, complete see whether it is a seepage or not, water table is there, and due to the water table, definitely the slope is under submergence or not. Yes, very good point. See, if I say steady seepage, first of all, it is going to be submerged only. Now, you observe what I am going to do. This is sigma dash, which is gamma dash into cos square I. And this is going to be tau, which is going to be gamma dash into cos square I. I hope everybody understood up to this point. Now, the basic difference between the submerged slope and a steady seepage slope. In the case of submerged slope, no flow, and here flow occur. Now you please tell me, my dear student, see, flow takes place from higher water level to lower water table. 1, 2, 2. Flow occurs from higher water table to lower water table. So along the direction of flow, you know there is one more pressure known as seepage pressure. So what is this? That is nothing but seepage pressure. Now I hope you remember this condition. So what is the basic difference that defines between the submerged slope and the steady seepage slope is going to be this seepage pressure. See first, sorry, cos I sin I. Okay, cos I sin I. Okay, now look, you know that if there is a seepage, along the direction of flow, there is a seepage pressure. Yes or no? And now, whatever the seepage pressure, you please tell me, whatever the seepage pressure, now along this seepage, the seepage pressure would be there. So, as I told you, whatever this depth is nothing but the Z, the depth is going to be Z. So, that seepage pressure is going to be like this seepage pressure is going to be like gamma W into Z cos I sin I. Either you take this way or that way. Either you take this way or earlier way. Now, at first I explained the submerged and steady is going to be same. But now, due to steady seepage, there is a seepage pressure which acts along the direction of flow. Keep that in your mind, which acts along the direction of flow. So the net force over here is tau plus S, which means, so the net shear stress, this is going to be tau dash, or let's take a tau only. So the net shear stress is going to be the gamma dash into Z cos I sin I. See, this cos I sin I is nothing but a component due to the slope. Due to the slope only it came. If there is no slope, there is no cos I sin I. Yes. So now you tell me gamma dash into Z plus gamma W into Z. What is this? Gamma sat into Z cos I sin I. So some of the students were asking me, sir, why the factor of safety is going to be decreases? My dear, understand it carefully. Does the seepage pressure acts along a shear stress, means along the failure plane or opposite to the failure plane? Along the failure plane. Now you tell me, if along the stress, this is the developed stress, right? Due to seepage, as the seepage moves down, as along the shear stress, the net stress is going to be increases or decreases? Increases. So now you tell me, what is numerator? Gamma dash into Z. What is denominator? Gamma sat into Z. So in this case, factor of safety is equals to gamma dash into Z cos square I tan phi dash by gamma dash into Z cos I sin I, because for C is equals to 0, means quotientless soils. Okay, so now everything will get cancelled, then factor of safety is equals to tan phi dash by tan I. Now coming over here, what is the factor of safety over here? So gamma dash into Z cos square I tan phi dash by, now due to seephase pressure, right? Due to seephase pressure. Okay, first I'll write this one in this way. Sigma dash tan phi dash by tau plus PS, because you know factor of safety is nothing but resisting by causing. Resisting by causing, yes or no? So now who is causing over here? This is a causing, tau, and along this direction seephase pressure is also going to be there. So now I have to add both. See now, which is going to be increases, my dear? Causing is going to be increases or resisting is going to be increases? You see the numerators in both the cases. Factor of safety, here the numerator gamma dash into Z cos square I tan phi dash by, now gamma sat into Z cos I sin I. The basic difference between these two is going to be here gamma dash, and here is going to be gamma sat. Why, sir? Due to the seephase, sir. So I hope if you still have any doubt, I have explained you. This is a conventional way. This is the conventional way, and this is a logical way. The logical way is due to steady seephase, there is a seephase pressure, and that seephase pressure, this component is going to be cos I sin I, and the seephase pressure is going to be gamma W into Z. Z is not slanting, Z is a vertical depth, Z is not going to be slanting. You could be, please go through the basics. I explained you by taking the Z as a vertical only. So now, yes, I hope you understood. So with this, I can find out the factor of safety as gamma dash by gamma sat into tan phi dash by tan I. So yes. So now, so compare these two. If you compare these two, then the factor of safety would be less in the case of the steady seephase. So this is other way of explanation I have made. This is one way of explanation. This is other way of the explanation. So my dear students, I want you to focus on one thing over here. The focus is going to be like, look, no matter what, finally I am giving you conclusion as, see, at the end, in the numerator, I am asking you, you go with the gamma dash values. And in the denominator, you go with the gamma sat values. See, if you don't want to follow all these things, I have a small logic. So whenever there is a steady seephase which is parallel to the slope exists, you simply take gamma dash in the numerator and denominator gamma sat. That's it. You don't go beyond that. Gamma dash, and this is going to be gamma sat. So now I'll give you one more condition for you. Again, seephase parallel to slope at some depth below slope surface. At some depth below slope surface. So C pays parallel to slope and at some depth below the slope surface. This time there is a water table which is at some depth below the slope surface. This is a slope and now this is a steady sea phase which is parallel to slope and at some depth below the slope surface. Now let's say this depth as Z1 and here depth as Z2. So now my dear students, you please tell me what is the normal stress, shear stress and pore water pressure. So you know all these three, right? You know all these three. So now above gamma, below this is going to be gamma sat. So now you know that what is the total stress over here? What is the total stress? First I write with this one. What is the total stress? Gamma Z1 plus gamma sat into, write down over here, sigma gamma Z1 plus gamma sat into Z2 cos square I tau gamma Z1 plus gamma sat Z2 into cos I sin I. And what is pore water pressure? Gamma W into, what is this value? The water will rise up to this water table only, right? Z2 cos square I. So then the factor of safety is going to be equals to, see, if you don't want to go with all these things also, I have one logic. The logic is you take vertical stress as an effective stress and lateral. You see sigma minus u, right? That is going to be effective stress, right? So I can directly write that. What is the factor of safety over here? C dash plus. So now, my dear students, what is effective stress over here? Total stress minus pore water pressure. What is effective stress? Above gamma into Z1 plus gamma dash into Z2. See, I'm telling you again and again and again repeatedly, below the water table, in the numerator you take gamma dash, in denominator you take gamma sat. So gamma dash into tan cos square I tan phi dash by gamma into Z1 plus gamma sat into Z2 cos I sin I. You don't need to remember all these things. Do you need to remember all these things? I don't remember this. I don't remember this. I don't remember this. What I do is, in the numerator, this portion is going to be effective stress. In the denominator, this portion is going to be total stress. That's it. If you are intellectual enough, then you can go in that fashion. So I gave you all the models regarding to the infinite slopes. So I gave you for sea soils and I gave you for the erosionless soils also. So simply, if I say erosionless soil, just keep C is equals to 0. So that's all. Okay, now let's go to the some problems regarding this. You see this problem, please. You see this, please. So now a granular soil deposit has a phi dash. What is the meaning of granular soil? Granular soil means C dash is equals to 0. I have explained you in a starting days itself. Granular means cohesionless soil and gamma z is 90. A slope has to be made of this soil at an angle of 28 degrees. So a slope is going to be made at an angle of 28 degrees. Now let's see, this is a classroom practice question. This is a classroom practice question. So at first you are making a slope whose angle is going to be 28 degrees. If seepage occurs parallel to the slope with the water table at a depth of 1.5. So there is a water table at a depth of 1.5. Now the factor of safety of slope against the translation failure. See, they are mentioning the translation failure. What is the meaning of translation failure? This is going to be infinite slope. So far we have been discussed about the infinite slope only, right? At a depth of 4 meters would be. So at a depth of 4 meters, so now my dear students, look, the water table is going to be located at a depth of 1.5 meters. What they're asking is at a depth of 4 meters, what is the factor of safety? See, they are giving some plane and they're asking you the factor of safety. Understood or not? Okay, fine. Now let's see. This is a water table. Did they mention, see, above gamma, below is going to be gamma sat? Yes. Above gamma, below is going to be gamma sat. As gamma is not mentioned, assume gamma is equals to gamma sat. Okay, first write down the total equation, please. Just now, you know everything, right? This is I, and you know everything. Now, I don't want to write normal stress, pore water pressure, and effective stress. Directly, I say one point in the case of the examinations. In the case of the examinations, I'll say directly F is equals to C dash plus. Now, you see the numerator, this is going to be cos square I tan phi dash. See, this is going to be common cos square I tan phi dash by some denominator into cos I sin I. See this cos square I, cos I sin I, how it came, I have been already explained. Now the question is entire these portions in the numerator and the denominator. I have taken a long time to explain these things. So now my dear students, what I do is once I write this equation, I am going to write in the numerator, I take the effective stress here, and in the denominator, I take the total stress. So now, here, first, what is effective stress? In this zone, gamma into 1.5 plus, I am asking you effective stress below the water table, gamma dash into, the total is 4 meters. Now, what is this depth? This is going to be 2.5 meters. But coming to the denominator, gamma into 1.5 plus, now I am going to use gamma sat into 2.5. If you have any doubt, just now I explained this one. You see, gamma into 1.5 plus gamma dash into 2.5 by gamma into 1.5 plus gamma sat into 2.5. I hope you understood. So now, as C is equals to 0, one cos will get cancelled. Then finally, the factor of safety is equals to gamma into 1.5 plus gamma dash into 2.5 by gamma into 1.5 plus gamma sat into 2.5 into tan phi dash by tan I. Tan phi dash by tan I. I'm asking you this value. So my dear students, so you please tell me. So the values are there, everything is there. So come on, solve it and let me know the values, please. Factor of safety. What is gamma? Gamma is going to be gamma sat only. How much? It is going to be 19 into 1.5 plus gamma dash, gamma sat minus gamma W So 19 minus, as I did not mention anything, you have to take gamma W as 9.81. Mind it, if it is a numerical type, always you take gamma W 9.81 if they don't mention. If it is a multiple choice, then you can take it as 10. 9.8, 9.91. So 9.91 into 2.5 by 19 into 1.5 plus 19 into 2.5 into tan 35 degrees by tan 28. So what is the factor of safety, please? So the factor of safety, this is going to be 0.89. If you solve, the factor of safety is going to be 0.89. So now the factor of safety is going to be 0.89. So what is the meaning of the factor of safety 0.89? It is going to be fail or not? Is it going to be fail or safe? That is going to be fail. So now what I do is, kilonewton per meter cube. That's gamma sat. Gamma sat 19 minus gamma W 9.81. So I can write directly. I don't have a space over here, so that's why. See, now I will analyze this question further. I will analyze this question further. In this question only, I am going to analyze fully. Listen to my students here. Sir, the meaning of factor of safety 0.8 means less than 1 or more than 1? Less than 1, which means the slope is going to be fail. Which means the slope is going to be fail. So what is the slope angle I have mentioned over here? This is I. And what is I value? 28 degrees. So if you provide a slope of I value as 28 degrees, then there is a failure. Yes or no? So now my question for you is, what is the slope that you can provide for a critical factor of safety? So what is the minimum slope that you provide for no failure? Now I'll be adding one more question in this. Please look over. Is this 9.19 point? Sorry, 19 minus 9.81. Oh, sorry. This is 9.19. No? Sorry. 9.19. Yes, okay. So now I'm going to add one more point over here. B, minimum slope angle required for no failure. See, minimum slope angle required for no failure means, see, this is less than 1, which means it is going to be fail. Yes or no? So now I'm asking you, I want to explore this question much more. See, I got whatever the factor of safety at a depth of 4 meters is going to be 0.89. At the same depth of 4 meters, if I want to go for the minimum slope, what is the minimum angle that I have to provide that should not cause any failure? That should not cause any failure is, so now if you find out for no failure, then the factor of safety is equals to 1. When the factor of safety is equals to 1, now factor of safety is equals to gamma into 1.5 plus gamma dash into 2.5 by gamma sat into 1.5 gamma into 1.5 plus gamma sat into 2.5 tan phi dash by tan I. Now, for the minimum slope angle required for no failure, I take factor of safety is equals to 1. Then you take this tan I over here. This tan I is equals to, what is gamma? 19 into 1.5 plus 9.19 into 2.5 by 19 into 1.5 plus 19 into 2.5 into tan phi value. What is the phi value I have here? 35 degrees. So come on, please tell me the I value. Come on, please tell me the I value, please. See, this is the next question. Means I am adding an extra one. I know that the factor of safety is going to be less than 1. So I want to make sure the soil is going to be safe. For that, what is the minimum slope I have to provide? The minimum slope is going to be provided as 19 to 1.5 plus 9.19 into 2.5 by 19 into 4 into tan 35 and also function. So 25.37 degrees. So my dear students, if you provide a slope of 25.37 degrees, then the factor of safety is equals to 1, then there is no failure. You please observe, if I provide 28 degrees, factor of safety is less than 1. With our common sense, okay, the slope is too much. So what we need to do is we have to provide a slope little bit less than that. Initially 28. Now for the same question, if I go for the I value as 25.37 degrees, then there is no failure because the minimum slope, if you provide a minimum slope 25.37, so then there is no failure. If you provide less than that also, there is no failure. Okay. So I hope you understood 25.37 degrees. Now, let's take one more topic over here in this, because I am covering all the previous gate type of questions with this. Okay. The critical depth at which slope is at verge of fail. Now this time I am asking you, see, I am not going to change any slope. I am not going to change any slope. The slope is going to be 28 degrees only. See, I got at 4 meters, the factor of safety is going to be 0.89. Yes or no? Which means before 4 meters itself, there might be a failure or not. So what is the depth or critical depth at which there is a verge of failure? So now again the factor of safety is equals to 1. When the factor of safety is equals to 1, now again the same equation, gamma into 1.5, but this time you don't know the depth. You don't know the depth. Let's take it as a sum z only. So let's take it as a sum z. So now you see plus gamma dash into, yes. So gamma dash into, see this portion. Let's take the total depth as z. Let's take the total depth as z. So now you know this is going to be 1.5. Now I'll write gamma dash into z minus 2.5, z minus 1.5, z minus 1.5, because I don't know at what depth, right? See, earlier I gave you 4 meters. So 4 minus 1.5, this is going to be 2.5. Now I'm finding the depth at which the factor of safety is going to be 1. So by gamma into 1.5 plus gamma sat into z minus 1.5 into tan phi dash by tan I. Look here, factor of safety is equals to 1 gamma 19 into 1.5 plus 9.19 into z minus 1.5 by 19 into 1.5 plus 19 into z minus 1.5 into tan 35 by tan 28. So you please find out the z value. Please find out the z value. What is the z value? Please let me know. Please solve this and let me know the z value. Mr. Nikhil sir, can't we use F inversely proportional to tan I and solve this? Yes, you can solve that, but I want you to look over the procedure. That's why I have given this procedure. What is the z value you are going to see? Okay, I'm sorry, this is not a minimum slope, or this is a maximum slope angle required. Maximum slope, sorry. This is maximum slope angle required for no failure. And if I is more than 25.37 degrees slope failure occurs. So that's a maximum slope angle required for no failure. Okay, fine. Whatever it is you do, you can take this one as only x. You can take this one as c. This z 1.5, and this is going to be x. You can take this as a 1.5, and the small portion is going to be x. Then you can find out the z also. So because then if I go, then people will ask me, sir, why you take x and all those things. That's the reason why. So what is the z value you got, please? Z value you're getting 2.813. 2.813. Even I did not solve, whatever the solution given by our student. So I have written, if you got most of the people as Z value 2.813. See, I'm just. So what about phi angle? Phi angle is not going to be changed because that's going to be soil, right? That's going to be soil. See, in this question, I have explained you different ways. What are the different ways here is, number one, for the given data, I find out the factor of safety. Number two, what is the slope that you can provide for no failure? 25.37 degrees without changing anything. I'm not changing the depth, I'm not changing anything, but I'm just finding the value of I. Now, sir, I'm not going to change the slope. I will provide the same slope. I will provide the same details, but at what depth the failure is going to be started for, sir? That's going to be 2.813. Is it true? 2.813? What is the conclusion if we took maximum slope in the case? What is the meaning? See, if you provide this much slope, factor of safety is equals to 1. Yes. And if you provide I greater than this one, then factor of safety is going to be less than 1. Failure is going to be occurs. So the conclusion is, if you go for 25.37 degrees at 4 meters, soil is going to be slow, safe. And if I want to go with the same 28 degrees, then the Z I can go is 2.813 meters only. So you please solve and that's about this condition. Yes. So with this I have covered all the models now. This is question number 2. Here is a question number 2. So my dear students, here is a question number 2. An infinite slope is made of clay which has gamma sat, gamma dash and slope angle, and there is a C pace parallel to the slope. See, the meaning of this one is there is a C pace parallel to the slope. Directly they have given. And what is the critical height? Now the Z is nothing but HC. Just now we have find it out, right? Just now we have find it out, right? You know that factor of safety is nothing but so in the numerator gamma dash into Z, there is C value also, C dash plus gamma dash into Z cos square I tan phi dash by gamma sat into Z cos I sin I. Now when Z is equals to critical height, then factor of safety is equals to 1. Just now I explained the model. The critical height or depth at which slope is at verge of failure. Then factor of safety is equals to 1. So now you substitute these values. When the factor of safety is equals to 1, then I can write gamma sat into Z as HC into cos I sin I is equals to C dash plus gamma dash into HC cos square I tan phi dash. You please solve this and you get down the values because you have everything. Gamma sat they have given 18 into HC into cos I sin I. Cos, what is I value? Slope angle 35 degrees. Cos 35 into sin 35 C dash 25 plus 9 into HC into cos square 35 degrees into tan 28 degrees. You find out the HC value. It's up to you. I'm giving you as a homework for this because HC value, right? That's all. They have given phi dash. You please look over that. What is HC value you got? Please let me know the HC values. Is it 4.753 something like that? Here will I also calculate. Into cos 35 into sin 35 minus 9 into 28 into cos. So I hope you people have got the 4.765. If I round it to 2 decimals, then it is going to be 4.77 meters around to 2 decimals. I hope you understood this. Please look over this question. GATE 2019, set 1. In the case of the ESC, they won't give this type of questions. They will give you directly the gamma dash. See, if they in ESC, the type of question they can provide you is for the corrosionless soils. They won't go for the corrosive soils. This chapter is important for GATE. So if you see the GATE 2019 set 1, a granular soil again, granular soil. What is the meaning of granular soil? C0. And what is the phi I am giving? 30. Gamma sat as 20 kilonewton per meter cube. Unit weight of water 9.81 kilonewton per meter cube. Now, so a slope is to be made on the soil deposit in which seepage occurs parallel to slope up to free surface. A slope is going to be made and in which seepage occurs parallel to the slope up to free surface. Under this seepage condition, for a factor of safety of 1.5, the safe slope that should be, look, the unit weight of water is going to be 9.81. A soil is to be made on the soil deposit in which the seepage occurs parallel to the slope up to the free surface. So now this is the condition. And Z, what is the slope angle I for a factor of safety of 1.5? So they did not give the Z value, sir. You don't worry, sir. Finally, sir, what is this, sir? C0, sir. C0, sir. When factor of safety, then can I write directly gamma dash by gamma sat into tan phi dash by tan I? Yes or no? Gamma dash by gamma sat into tan phi dash by tan I, because I have already explained this condition, right? What is meaning? You see, if the water table is going to be parallel to the seepage, then what is the factor of safety? Gamma dash by gamma sat into tan phi dash by tan I. Mind it, you have to look over the conditions over here. You cannot just write it directly as a blindly. They have given C0 and water table is going to be near to the slope surface. Then this is the equation. So now I want I value 1.5 is equals to gamma dash 20 minus 9.81 by 20 into tan phi dash. What is the phi dash? 30 degrees by tan I. Find out the I value. So you can get as 11.089, but they're asking rounded to 1 decimal. Rounded to 1 decimal, 11.1 degree. See, you please look over. If you keep your answer 11.089 also, you are not going to get the correct answer. Means you're not going to get the marks. You have to look over how many decimals they are looking. 1 decimal. So 11.1 degrees. Answer is going to be 11.1 degrees. This is the previous GATE question. Now, I hope you understood this. Let's go for the next question. Can I? Yes, I do. See, in class I will be explaining big models. Means, so the type of models which are going to be a little bit complicated. Now, you see, this is the condition, and this condition you observe. Okay, for this, for first we go for the infinite, then we go for the remaining things. Now, you please observe, this is a very good question in GATE 2013. Listen to me once. The soil profile above the rock surface for a 25 degrees infinite slope. See, the slope is going to be 25 degrees. Where SU is the undrained shear strength. You know the undrained shear strength. SU is nothing but CU only. Because undrained shear strength. You please remember the undrained shear strength. There I said you The SU is nothing but the CU. And what is the meaning of undrained shear strength? Phi is equals to 0. Phi U is equals to 0, because if I say S is equals to undrained shear strength, that is going to be CU. So whatever the shear strength they mentioned directly, the mentioned is going to be shear strength directly. Okay, fine. Now the slip will occur at a depth of, see, they have given this. Now my dear students, there are two soils. Soil A is there, soil B is there, and there is a SU. Undrained shear strength in soil 1 is 40, and undrained shear strength in soil 2 is going to be 60. Soil 1 length is going to be 5 meters, soil 2 length is going to be 5 meters, means depth is going to be 5 meters. Now the slip will occur at a depth of, now if it is a homogeneous deposit now, then I can directly take, you see, yes. So the slip will occur, the critical depth at which slope occurs, means slip will occur. I can take directly factor of safety is equals to 1 if it is a homogeneous deposit. But the given question is not a homogeneous deposit. It is a layered deposit. So slip may occur either in soil 1 or soil 2. Slip may occur in either soil 1 or soil 2. So if it is going to be occur in soil 1 or soil 2, now let's see. Trial 1. If slip occurs in soil 1, which means, so what is this depth? This depth is going to be 5 meters. And what is gamma I have given? 16. As there is no water table, SU 40. So factor of safety is nothing but shear strength by shear stress. Yes. So here SU by what is shear stress? You know, gamma z cos I sin I. Because this is infinite slope, right? This is infinite slope, and they have given the shear strength directly. You don't need to worry about finding the normal stress, because they mentioned the shear strength. What is this shear strength? They mentioned it, and you know the tau is nothing but gamma z cos I sin I. If you have any doubt, you please go back. Now, if a slip occurs in the soil 1, let's check. If slip occurs in the soil 1 or not, let's check. Find out the factor of safety for SU1. 40 by gamma into z. Gamma is 16 into z. 5 into cos I. What is I? 25 into sin I. 25. So please find out the factor of safety over here. Please find out the factor of safety over here. By 16 into 5 into cos 25 into sin 25. So which is going to be 1.3. So this is greater than 1. So slip will not occur in soil 1. So now see, my dear student, what I'm doing is I don't know where the slip is going to be happen. So let's assume the slip is going to be happen in the soil 1 at this plane. So I don't know. And as I don't know, I have find out the factor of safety in the soil 1, and I got to know the shear strength of the soil 1 is going to be 40. So numerator is going to be 40 and denominator is going to be gamma z cos I sin I. See, they have given you the shear strength directly. You don't need to worry about finding the normal stress. Yeah, seeing options, you can eliminate first one, but you cannot go directly, right? Yeah, see in the examination, see I'm going to take an entire procedure. I'll say you the logic at the end. Now, if you observe, see the options over here. If you observe the options are, the failure is going to be happen at a depth of more than 5 meters only. Yes. So they're asking the Z. See, definitely the slip is going to be happen in the soil too. So now slip or failure occurs definitely in soil too. See, somebody may ask me, sir, why not soil one? That's the reason why I have told you this one, factor of safety is equals to 1. Now, what I do is, now the logic is, you can see the options, you can eliminate the slip one, means trial in the soil one. Now I can go for the soil 2. I don't know at what depth. So this is the Z I want. But you know, this is going to be 1.5 meters. Let's take this as X only. Let's take this as X only because I have solved, I have given you this type of question earlier also. I have given you this type of question earlier also. So now let's find out. So at verge of failure, factor of safety is equals to 1. At verge of failure, factor of safety is equals to 1. So now, can you please write down the equation over here? Because here the strength in the soil 1 is going to be different and the strength in the soil is going to be different. You have to take the total strength, right? So now, what is the strength over here? Please check. So shear strength by shear stress. So soil 1, the sorry. Okay, sorry, this is not a 1.5 meters, this is a 5 meters. So now in soil 2, soil B, what is the shear strength I have given you? What is the shear strength I have given you? 60. So SU2 by tau. What is tau now? Now the tau is going to be, you see, gamma 1 Z1 plus I can write down this value. You please go through over here. So what is gamma? Gamma 16. Gamma 1 16. And what is gamma 2 here? 20. So now you see 16 into 5 plus 20 into x cos I sin I. 16 into 5. See, in this case, the tau is going to be gamma into z. 16 into 5 only. But here, as we are discussing about the soil 2, what is the strength in the soil 2? SU2. So now the factor of safety, if I take the factor of safety is equals to 1 at verge of failure, at the verge of failure, it is going to be 1. Then what is SU2? SU2 given as SU2 is going to be 60 kilonewton per meter square. So 60 is equals to 16 5s plus 20 into x cos I. I means 25 degrees into sine 25 degrees. You please find out the x value. You please find out the x value. 60 by cos 25 into sine 25 minus d by 20. So I hope the value is going to be x as 3.83 3.832. But now the total depth is going to be 5 plus 3.832. which is going to be 8.83. From the given options, answer is going to be 8.83. Option answer as A. I hope you understood. See, that's the reason why. That is the reason why I have included all these things in the earlier itself. You see, the critical depth at wedge of the slope is going to be a factor of safety is equals to 1. So here in this question, directly they mentioned. In this question, directly they mentioned. So at what depth it is going to be failed? The minimum depth, the slip will occur. So I am checking the slope 1. So whether it is going to be safe or not, then I went for from the options. You can say from options directly. From options, slip will occur in soil 2. So this is one of the previous gate question, and this is one of the previous gate question based upon this chapter, means based upon this infinite slopes. Now these are some of the questions that we'll see later. Yes. I hope you understood this topic clearly. Sure. So why didn't you add SU1, sir? Sir, what is the meaning of SU, sir? SU1 means strength, sir. We're discussing about soil 2. We have to take the strength of the soil 2, right? Why did soil is given as SU1, sir? That's their wish, sir. Whatever they want to do, they will give you, sir. If you want to take the slide, those who want to take the slide, you please take this slide. I hope you have done with this. If you have completed, let me go for the next topic. In Hyderabad also the climate is not good. Actually, so now I hope you understood the conditions. Let's see some of the basic definitions of the of factor of safety. See, whatever the definitions I have made for the given slopes, but now what are the basic definitions? Some basic definitions. So in that, number 1, factor of safety with respect to shear strength. Factor of safety with respect to shear strength. So now factor of safety with respect to shear strength over here. See that I am going to represent with Fs is equals to shear strength by I will write you as yes, actual shear strength by mobilized shear strength or applied shear stress. So what is the meaning of this one, sir? See, you know that factor of safety is nothing but a shear strength by shear stress. Now I am going to write it as S by Sm. Now I am going to write as simply S by Sm. See, you know, factor of safety means shear strength by applied shear stress. So then what is the meaning of this mobilized shear strength, sir? First of all, the meaning of the mobilized means developed. Mobilized means developed. So now let me take myself as an example. My dear student, you please listen to me and understand this condition. So far you know the applied shear stress and all those things. Now I am changing the term from the applied shear stress to the mobilized strength. Why, sir? Now you please observe. Let me take myself as a soil mass. My actual strength is going to be 50 kilopascals. Let's say my actual strength means I can take a shear stress up to 50 kilopascals. Yes or no? So now my strength, let's say 50 kilopascals. Now you apply some load. Now you apply some load of 10 kilopascals. My dear, you apply 10 kilopascals. Due to the 10 kilopascals, some stress will develop inside of me or not? Yes or no? Some stress will develop, means some strength will develop inside of me. How much stress you applied? 10. And how much strength it developed? My actual strength is 50. Do you think if you apply 10 kilopascals, my entire 50 is going to be developed, or the strength is going to be developed for the particular stress? Strength will develop for the particular stress. Now keep that in your mind. If you apply 10 kilopascals, how much strength should develop inside of me is a 10, not 50. So as you know, what is the actual strength of mine? What is the actual strength of mine? 50. And what is the applied stress you applied? 10. Then how much strength is going to be developed? 10. So whatever the stress you applied, that will be developed as a strength. For example, now you see my strength is going to be 50, but how much developed? 10. 50 by 10, factor of safety is more than 1, safe. Now you apply 20 kilopascals. Now you see, what is I applied? 20. But what is my actual strength? 50. So if I apply 20, how much strength should develop? 20. So you apply stress of 20, you apply stress of 20, then the strength will develop by 20. Then it is going to be known as a mobilized shear strength. And if you apply 30, the strength should develop 30. If you apply 40, the strength should develop 40. But actual strength is 40. If you apply 50, now you see, if you apply stress of 50, the strength developed is also going to be 50. Now you tell me, what is the actual strength of mine? 50. What is the stress applied? 50. What is the strength developed? 50. Then what is the factor of safety? 1. Then the soil is at a verge of failure. Now you see, Baba, I'm going to apply 60. But what is the actual strength? Only 50. So my strength is 50, but you are applying 60. Do you think, does the resistance is going to be developed up to 60? No. Then the soil is going to be failed. So keep that in your mind. Now the same equation means the shear strength, I'm going to write in terms of the mobilized, applied shear stress or mobilized shear strength. So now I can write the shear strength as C plus sigma into tan phi by Cm plus sigma into tan phi m, where Cm is mobilized cohesion or developed cohesion. Phi m is mobilized friction angle. See, you know that when you apply load, corresponding to that load, the soil will give some resistance. Yes or no? And that resistance developed is nothing but the mobilized resistance. So now let's see. If you observe from this, I can write Cm plus sigma into tan phi m is equals to C plus sigma into tan phi. C plus sigma into tan phi by Fs. Okay. So now you please observe, can I write this one as further Cm plus sigma into tan phi m is equals to C by Fs plus sigma into tan phi by Fs. How we develop cohesion? We don't develop cohesion due to the stress. The interparticular attraction is going to be developed or not. That's why the cohesion is going to be developed. So now you see, I can compare. I can take the Cm as a C by Fs, and I can take tan phi m as a tan phi by Fs. So C by Fs. From this I can write Cm is equals to C by Fs, and tan phi m is equals to tan phi by Fs. Look, this is a factor of safety with respect to shear strength. And first one, this is going to be with respect to shear strength, where Cm is going to be C by Fs, and tan phi m is going to be tan phi by Fs. And similarly, second one, factor of safety with respect to cohesion. If I go for cohesion, which means phi is equals to 0. So now the same factor of safety, you please look, C plus sigma into tan phi by Cm plus sigma into tan phi m. Now you see, if I say cohesion is going to be 0, this entire terms are going to be 0 or not? This entire terms are going to be 0. Then this is going to be Fc. Similarly, factor of safety with respect to friction, then you are going to keep C as 0. Now go back. If I keep C as 0, then cohesion is 0, then how come the mobilized cohesion will come? Cm is also going to be 0 or not? When C 0, Cm 0, sigma will get cancelled. C 0, Cm 0, sigma will get cancelled. Then tan phi by tan m. Tan phi by tan m. Factor of safety with respect to friction is going to be tan phi by tan phi m. So I hope you understood over here. What is the factor of safety with respect to cohesion? C by Cm. What is the factor of safety with respect to friction? C plus sigma tan phi by Cm plus tan phi m. Now you please look over here. From this data, you can write this one as Fs is equals to C by Cm, which is equals to Fc. And this one as Fs is equals to tan phi by tan phi m, which is equals to F phi. Look, can I write this one? See, I did not write this one earlier. Then I came over here. I told you this is a factor of safety with respect to cohesion. This is factor of safety with respect to friction. So now from these details, I can write the C by Cm as Fc and tan phi by tan phi m as F phi. And from this, so if you look over these conditions, I can write this one. Generally, the factor of safety with respect to shear strength can be written as factor of safety with respect to cohesion in terms of clays. In clays. And here Fs is equals to F phi in the case of cohesionless soils. So now I can write a note point over here. Generally, for analysis, we take Fs is equals to Fc is equals to F phi. Fs is equals to Fc is equals to F phi. So generally we take Fs is equals to Fc is equals to F phi. So now this is the condition. Generally for analysis we take Fs is equals to Fc is equals to F phi. And apart from that, the last one is Fourth one, factor of safety with respect to height. Factor of safety with respect to height. So if you cut a canal slope, this is a canal slope, or if you cut an excavation, this is excavation slope. Let's take the slope thickness is going to be, means slope height is going to be h. Slope height is going to be h. What is the factor of safety? See, you know, the maximum height up to which no support is going to be required is nothing but HC. HC means critical height. So what is the critical height? Height up to which slope can be provided without any support. Without any support. See, without any support, I can write down the HC, means I can do, if I go for the vertical cut, this is vertical excavation cut, or this is going to be inclined. Whatever it is, what is the maximum height that you can go without any support, that is going to be HC. So now the factor of safety with respect to height is equals to critical height HC by H. Critical height HC by H. Sir, how come I find out the critical height, sir? You know that critical height HC is equals to 2 times of ZC. I hope you remember 4C by gamma root Ka. 4C by gamma root Ka. If it is a pure clay, pi 0, Ka is equals to 1. So these are some of the factor of safety, sir. See, sometimes in examinations, sir, they will provide you the factor of safety. They won't give you the type of slope. They won't mention the type of slope. They won't mention you whether it is going to be horizontal, means finite slope or infinite slope. They will simply say the factor of safety with respect to height or cohesion or friction. I hope you understood this. This is not going to be possible for the cohesionless soils. Not suitable for cohesionless soils, because in the case of the cohesionless soils, C is equals to 0. When C is equals to 0, then H is equals to 0. This is not going to be possible for the cohesionless soils. That's a factor of safety with respect to height. It can be possible for C5 soils and clayey soils. Now I'll give one question and then I'll conclude. I'll give you a break because you see this question. This is a previous gate question. An infinite slope. This is an infinite slope. So just now we have been discussed. This is going to be infinite slope, making an angle. What is this angle? 35 degrees. Is subjected to C base parallel to its surface. C base parallel to its surface. The C given as a C dash 100 kilopascals and phi dash 30 degrees. Using the concept of mobilized cohesion and friction. Just now, what is the meaning of CM? Mobilized cohesion. What is the meaning of phi M? Mobilized friction. So at a factor of safety of 1.5 with respect to shear strength, the mobilized friction angle would be. The mobilized friction angle would be, they are asking what is the mobilized friction angle. So just now I told you, generally for analysis I take the factor of safety with respect to shear strength as any value, factor of safety with respect to cohesion and factor of safety with respect to friction. Now, by using that concept only, by using generally factor of safety with respect to shear strength is going to be factor of safety with respect to friction. So what is the factor of safety of 1.5 with respect to shear strength? 1.5. And now you tell me what is F5? F5 means tan phi by tan phi m. So as you know, Fi is equals to tan phi by tan phi m. They have given the tan phi because there is an inclination due to this phi dash. Then what is the tan phi m, please? Tan 30 degrees by 1.5. From this, what is phi m value? Please find it. What is phi m value? Tan 30 by 1.5 and most of answer, which is going to be 21.05 degrees. The answer is going to be 21.05. See, they are asking using the concept of mobilized cohesion and mobilized friction. So from that, I can write at a factor of safety of 1.5 with respect to shear strength. I can take the factor of safety with respect to shear strength as factor of safety with respect to friction. So if you want, if you have any doubt, please go back over here. Here I mentioned it clearly. I can write down this tan phi m is equal to tan phi by Fs also. So this is a portion of 2 points. I can just simply add these things. That's it. So did he give to C to fools us? If they would have asked a mobilized cohesion also, you can find it. You see this question, please. See, I asked a mobilized friction angle, right? Similarly, I am asking the CM also. Can you please tell me? I am asking the CM also. If I ask you CM, mobilized friction, then I can take FC is equals to F. Fs is equals to FC is equals to C by Cm. Then what is C dash? So C dash 100 by 1.5. What is this value? Which is going to be 66.67. So I asked you mobilized friction angle, then you can find out the mobilized value. See, when I mention, I'm telling you again and 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 again. If I say mobilized means, then whatever the shear strength factor of safety they can give, that you can use it as factor of safety with respect to friction and factor of safety with respect to cohesion also. If they would have asked this question, then this is the answer. But as they have asked this question, then what is the answer? 21.05 degrees. So with this, I conclude these things. Okay, fine. Let's have a break. It's 11:24. See, sir, some of the people are asking. I'm not able to send any message in your Telegram channel. No, the Telegram channel is not working out, so I deleted that Telegram channel. You please follow. You please follow the official ACE channel. There also I'll be there. Sir, if we learn only formulas, we can get good marks in GATE. No. Okay, let's have a break. It's 11:24. Have a break of 15 minutes, and after that we'll be having next topics. So we'll see that topics. Okay, I have a break of 15 minutes. Welcome back, everyone. So, meanwhile, while the people are able to attend, I hope everybody knows this locust attack. Locust attack, I hope everybody is known, and especially it has been hit hard in Rajasthan, in Madhya Pradesh and Maharashtra also. It's going to be hit apart. And right now, along with the COVID, we are fighting with this locust attack also. And this locust attack, it's the worst scenario seen from the last 27 years. Locust attack. So in Telugu, we call it as a Midata in Telugu. But in general, we call it as a locust attack. Yes, locusts. Right now, the people in Rajasthan, locusts. So whatever the locust attack we are facing now, it's a largest one, and it is the worst one compared to from the past 27 years. 27 years back, this type of scenario has came, and after 27 years, so again this locust attack has been done, and you see whatever the locusts that we got, they have traveled from Iran and through Pakistan. It ended into the India, and they use whatever the radius. See, these locusts, they just goes like a spam, means the entire group is going to be moose. Okay, so the entire group is going to be traveled. See, the length of the locusts, they have traveled around 2 to 3 kilometer. So 2 to 3 kilometer length they have traveled as a group. Means that many, which means millions of locusts have been entered into India right now. And within a short span of time, it is going to be moved to all over the India. And right now, all the state governments are, so the agricultural department, they are taking measures for spraying the chemicals required to make sure that locusts will die. And the lifetime of a locust is going to be 90 days, which means 1.5 months. So within 90 days, it can destroy all the crops. It can destroy all the crops. So in its lifetime, one locust, in its lifetime, the lifetime of one locust is going to be 90 days. In its lifetime, one locust can eat a food which is equivalent to the food required for 2,500 people. Whatever the food required for 2,500 people, one locust can eat that food. And just imagine, millions of locusts are eating the farms now. And especially in Rajasthan itself, around 5 lakh acres of farmland has been affected by the locusts. So we are under a situation that we don't know what to do, and we don't know when the vaccine is going to become, and we don't know when the normalization comes into our life, and day by day our economy is going to be falling down, and we never know what is going to be happen tomorrow, what hits us hard tomorrow. And one side there are cyclones, other side locust attack, and all over the India there is a corona. And apart from that, the middle class person is losing their economy like anything. And not only the middle class, poor, and whatever you see, the top class also, rich people also. So don't think that rich people they have money, they are lost. But don't think that, because once the laborers or workers in a industry is not working over there, are not willing to come, the company has no other option. They can shift to other countries. They will shift to the other countries. So when an industry is going to be shifted to other country, that is going to be huge loss for the economy. Because at the end of the day, if there is no production of the work, the companies are not going to be earn money. So they also losses lakhs and crores of money through these projects and all. So it is going to be effect for each and everyone. Yeah, some movie is there. Means Surya movie is a Bandobast movie, so you can watch that movie. I have watched. Seriously, this 2020 is worst. And China attack one side, Kashmir POK. No, these are not the attacks of the Yugantham. Don't use China app. I don't use any app. Actually, I use social media very less. In fact, to say I don't know what are the exact features in WhatsApp also. And recently, I got to know how to use WhatsApp web and Insta or any other apps. I just know the names and basic things. I don't know the much regarding to the social media apps also. Okay, fine. So now let's come to the point as lol, it's time to socialize. No, it's not time to socialize. It's time to make social distance. So don't socialize with everyone. Even your girlfriend or boyfriend are going to be a strong carrier of the COVID-19 now. Okay. And I hope you have heard about some news regarding this. In Delhi, there was one situation. So that situation like one person has got COVID and he has got COVID from his girlfriend, and after interrogating the police got to know that that girlfriend means his girlfriend has three more boyfriends. So first it attacked to one friend means one boy. So it attacked from his girlfriend, and his girlfriend has three more boyfriends. So and whatever this boy already has two more girlfriends. You see how this chain is going to be at from one boy and one girl, it is going to be goes to the n number of boyfriends and n number of the girlfriends. And I don't know how many of you are doing the same things. Mind it, if you are doing the same and if you are maintaining two or more, means one or more girlfriend or boyfriend, definitely you are going to be a carrier of the COVID-19. So keep that in your mind. Okay, fine. Now let's go. Let's come to the party. Okay, and let's come to the next one, infinite slopes. See, we have been discussed about the stability of the finite slopes. Now let's see what is the stability of the infinite slopes. Stability of infinite slopes. Again, here also there are some assumptions. We assume soil is homogeneous and failure occurs by rotation, slip surface. See that these are all things that I have been discussed earlier. Slip surface should be circular arc passing through toe. Slip surface should be circular arc passing through toe with some radius r. So these are the common assumptions. Again, I have set these assumptions in the earlier means yesterday's class itself while I was discussing about sorry. Okay. So while I was discussing about yesterday, you look over here. In the case of the analysis of the finite slopes, slip surface is assumed as a circular arc passing through that too. So this is the condition we are going to take now to find out the stability analysis of the finite slope. See this one. Now let's go with the same thing. Now let's come to the point. So what are the methods that we are going to use in the case of the stability of finite slopes? Finite slopes. So there are some methods that we are going to use to determine the factor of safety by using the means for the finite slope. So there are some methods, and the methods are: number one, phi u equals to 0 degrees analysis. Phi u is equals to 0 degrees analysis. And second one, Swedish circle method. And third one, Bishop's method. Fourth one, friction circle method. And fifth one is going to be Taylor's stability method, stability number method. So these are some of the methods that we are going to discuss to determine the factor of safety in the case of the finite slopes. In the case of the finite slopes. So now let's start one by one. Phi u is equals to 0 degrees analysis. Phi u is equals to 0 degrees analysis. By seeing this, we can say phi 0. What is the meaning of phi 0? Phi 0 means then the soil is going to be clay soil or not? Yes, I can directly say that suitable for clays. Suitable for clays. So now phi u is equals to 0 analysis, which is going to be suitable for the clays. So when it is going to be suitable for the clays, now one more thing, I said you this is going to be undrained. See, you remember the chapter number 13, the undrained conditions. I told you the undrained is used for the immediate or short-term stability. Means when you apply the load, immediately pore water will not dissipate. When the pore water is not going to be dissipate, such a type of condition is known as undrained condition. You know it very well. So if the rate of loading is going to be quick, undrained, so it is useful immediately after construction of earth dam. So this type of method is going to be suitable for immediately after construction of earth dam, and this is suitable only for the clay soils because phi is equals to 0. That is the reason why immediately means undrained condition. Now let's see how to go with this analysis. You see here, you know that the factor of safety is going to be, see whatever the factor of safety I told you, for anything you just see soil is homogeneous, failure occurs by rotation, and slip surface should be circular. So what is the factor of safety? Factor of safety means resisting moment by driving moment. Okay. Now, who is responsible for the driving? and who is responsible for the resisting. So my dear students, you please observe now. If you understand here, this is going to be rotation, and the rotation is due to weight of the soil mass. So soil slides due to its self weight in wedge portion, due to its self weight in the wedge portion, means whatever the failure wedge is there, right, in this wedge portion. Now my dear students, you tell me, whenever there is a moment, what is meant by moment? What is meant by moment? Moment means force into perpendicular distance. So moment means force into perpendicular distance. Here this is W, and you know this is going to be rotated with respect to the center or not. So X, that is going to be X. So what is this weight? W, and is going to be X. Who is responsible for that driving is nothing but weight. So what is the driving moment over here is the weight of the soil into X. So W means weight of soil. And how to find out the weight of soil, sir? Weight of soil is equals to density into volume of wedge, and gamma into area of wedge into 1. Sir, how come I find out the area of this wedge, sir? See, this is we are not going to do. This is going to be done by the surveyors. Area of wedge is measured by using planimeter. I hope in the surveying you may heard about this planimeter or some other techniques are there. Don't ask me, sir, how you are going to measure the area. That's not my issue. That's a surveyor's issue. He has to tell me what is the area, and then only we can find out the weight. Okay. So now soil will rotate with respect to center O. So what is the center? This is going to be the center O. So now you tell me, soil will rotate with respect to center O. Then the driving moment MD is equals to W into X. W into X. So what is mean by this W into X, sir? That W into X means that is a driving moment, where X is the lever arm from center of gravity with respect to center O. So whatever the center of gravity, this is center of gravity, right? From the center of gravity to O, center O, then that distance is going to be the lever arm. So see, in simple words, the moment is going to be force into perpendicular distance. And what is the force over here? What is the force over here? The force is going to be, yes, the force is going to be weight. Now let's come to the resisting moment. So now please observe, resisting moment is equals to resisting force into lever arm. Yes or no? Resisting force into lever arm. So what is the resisting moment, sir? MR is equals to resisting force into lever arm. Now my dear students, please look over this once again. Go back to here. So now I will look over only the resisting moment. So let me draw that again once again. Now you see, this is going to be the resisting moment, right? Yes. So the resisting moment is going to be a resisting force into perpendicular distance. The resisting moment is going to be resisting force into perpendicular distance, means lever arm. So now, whatever this, for everything, if I draw an tangent, see, for the arc, if I draw the tangent, this tangent is going to be the resisting force. The tangent is going to be the resisting force. Whatever this is nothing but the resisting force. And you see what is the lever arm? And the lever arm is going to be radius. So now can you please tell me what is mean by so now what is mean by resisting a force? The resisting force is nothing but, you see, this force, tangential force acting along the slip surface. See, whatever the force acting along the slip surface, that is going to be the resisting force. And what is the perpendicular distance r? So then what is the resisting moment? Resisting moment is going to be Fr into r. So Mr is equals to Fr into r. Okay, fine. Now what is Fr, sir? Fr, which is nothing but resisting force, is nothing but shear strength into surface area of arc. See, this is the common thing that I am going to apply everywhere. Please keep your mind over here. Look, at first I find out the driving moment. Yes, I hope you understood this. And now I am finding the resisting moment. What is moment? Force into lever arm. So this resisting force into the lever arm. Now along the slip surface, there is a resisting, right? And what is this resistance? What is the resistance? A shear strength. Mind it, my dear. Here, the shear strength is going to be acting along the slip surface or perpendicular to the slip surface. This is a slip surface, and the shear stress is going to be acting along the slip surface or perpendicular to the slip surface. Along. So whenever it is going to be stress, now shear strength means resisting force by area. Stress means force by area. Shear strength means shear force by area. Which area? Surface area of whom? Arc. So now I can write Fr is equals to shear strength into length of arc into 1. Because we don't know the perpendicular distance, right? See, whenever I represent area multiplied with 1, that is going to be perpendicular to the board. That's keep in your mind. Perpendicular to the board. So now the resisting force, I need to know the length of arc. How to find out the length of arc? Length of arc represented with L bar is nothing but r into theta into pi by 180 degrees. You know that the length of arc from the properties of circle, can't you find out the length of arc? Whatever the r into theta. This theta is also going to be measured for the given slip surface. So now you see, once we got these values, now everybody, what is the resisting moment? R, I can say for place, as you know, phi u is equals to 0 degrees. What is the shear strength? Cu plus sigma into tan phi u. So phi u is equals to 0, then S is equals to Cu. Then S is equals to Cu. When S is equals to Cu, now the resisting moment is nothing but resisting force into lever arm as R and S into length of arc into R. What is R? Now Cu into L bar into R. I hope you understood. I am splitting one by one so that you can understand much more easier. So when I split everything, now the factor of safety, resisting by driving, which is equals to, what is the resisting moment? Cu into L bar into R by W into X. So this is the final factor of safety. This is the final factor of safety. Look, why I made this 50 at the end is I know this is nothing but shear strength. Actually, the resisting moment is nothing but shear strength into length of arc into R. But in the case of the clays, you know that the shear strength is nothing but Cu. So Cu into L bar into R by W into X. This is what I want to show you. So you please look over how I determine the MD and how did I determine the MR. So MD is nothing but who is responsible for the failure? Driving force. Who is responsible? Weight. And who is responsible for the resistance? Resisting force. Who is responsible for the failure? Weight. Weight is responsible for failure, whereas shear strength is responsible for the resistance. That's it. Once we know this, again, there are two conditions. You know that whatever the weight is nothing but density into area of wedge, right? Whenever the gamma comes into the existence, now there are two conditions. Canal full supply. Condition. This is a canal cut. Is a canal cut. Now you see canal full supply condition. You observe whatever this is nothing but a finite slope or not. You see whatever this is nothing but a finite slope. So in the case of the canal full condition, in the case of the canal full condition, you see everywhere the soil is fully under submergence. When the soil is fully under submergence, then you know this is the slip surface passing over here. Yes or no? And whatever the weight you are going to take, this is nothing but the effective weight. So W is equals to W dash. Whatever the weight you are going to see over here, this is going to be weight, and this weight you have to take as submerged weight. You have to take it as submerged weight. So now use gamma is equals to gamma dash. This is similar to submergence condition. So you don't need to worry about the much analysis over here. What you need to look over here is if it is a canal full supply condition, then the soil will be under submergence state, because this water will easily seeps into the soil or not. This water will seeps easily into the soil mass, so that the entire soil will be under submergence. Entire soil will be under submergence. Then you use gamma is equals to gamma dash. And there's a one more condition. Canal sudden drawdown condition. Canal sudden drawdown condition. In the case of sudden drawdown, a moment, haven't you ever found out any moment? Without finding a moment means lever arm means perpendicular distance. Force into perpendicular distance. Easy stuff. If you feel this is stuff, I can write this into 2-3 steps. For the better sake of your understanding, I have written all these steps. So now coming to the canal sudden drawdown condition. In the case of the sudden drawdown means fall of water level. Drawdown means fall of water level. So from this condition, to, if water table falls suddenly over here, if water table falls suddenly over here, this is nothing but a drawdown. This is nothing but drawdown. Original after drawdown. Now what happens to the slopes? So now you take this is again a failure. Now along with the weight, there is a seepage will be takes place. Yes or no? Seepage will be taking place. So now along with the submerged weight, I have to take, this is a submerged weight. Yes. And along with that, due to difference in the water levels from 1 to 2, there is a seepage, and that is going to be like gamma W. So now here gamma is equals to gamma dash plus gamma W, which is nothing but gamma sat. So use gamma is equals to gamma sat. In the case of canal full condition, you go for the submergence condition, use gamma is equals to gamma dash. And in the case of canal sudden drawdown, due to 1 to 2, the flow will be seepage. Yes. And you know that seepage occurs along the direction of flow. So whatever, this is nothing but gamma dash, and here is going to be gamma W. Then the total unit weight is going to be gamma sat. So now from now onwards, what I am going to do is, whenever I say canal full condition, I am going to use gamma as gamma dash. Gamma as gamma dash, and in the case of the canal sudden drawdown condition, I'll use gamma as gamma sat. So this is about the means, if they do mention, then only you go with these conditions. Because if you see the weight, whatever the weight over here, in that weight, gamma into area of a wedge. Okay. So now if you see in canal full condition, as I said, use gamma is equals to gamma dash. What is the factor of safety? What is the factor of safety? Cu into R. I can write directly F is inversely proportional to weight. Yes or no? Yes or no? So now F is inversely proportional to gamma dash. Okay, fine. I can write like this. Factor of safety, F is equals to resisting moment, whatever the resisting moment, I write like this, by driving moment is going to be gamma dash into area of wedge. See, I am not taking anything because I want to look over here. What is going to be happen to the factor of safety? What is going to be happen to the factor of safety? In canal drawdown condition, gamma is equals to gamma sat. So factor of safety means resisting moment by gamma sat into area of wedge. So my dear student, I'm asking you, do you think the area of wedge is going to be changes? No. Do you think the resisting moment changes? No. What is the change over here is the unit weight of the soil. Here it is going to be gamma, and here it is going to be gamma sat. Means now you see, as the factor of safety is going to be inversely proportional to gamma dash. So compared to, you know that gamma sat, note, You know that gamma sat is more than gamma dash. So whatever the factor of safety in canal drawdown is less than factor of safety in full condition. See that F means full condition, means F means a factor of safety. So now you tell me, in the case of the infinite slopes, I told you that due to study seepage, factor of safety reduced by almost 50%, and landslides, infinite slopes fails mainly by the seepage condition. So worst condition is going to be seepage. And in the case of the finite slopes, due to canal full condition, now, my dear students, if the water level in the canal is going to be suddenly draw down, it's a factor of safety is going to be decreases. It's a factor of safety is going to be decreases. So in the case of infinite slopes, in the case of the finite slopes, the worst possible condition is canal sudden drawdown condition, because in the case of sudden drawdown, the factor of safety is going to be decreases. So that's about the theory over here. So this is the final equation. Now, so if you see, that's about the phi u is equals to 0 degrees analysis. The point that you need to know, number one, who is responsible for the failure, self weight, and what is driving moment, weight into x. Now, number two, who is responsible for the resisting force? What is resisting force? Shear strength into surface area. Where is that? X. Yeah. So now I hope. Yes. Okay. So now that's about this canal phi u is equals to 0 degrees method. And next one is Swedish circle method, and this is also known as method of slices. Swedish circle method, this is also known as okay. Swedish circle method. This is also known as a method of slices. Why we call this as a Swedish circle method is this analysis has developed in Sweden. In Sweden, the country. So there, this method has been developed. So that's the reason why this method has been named as a Swedish circle method. This is also known as a method of slices, and this is suitable for all soils and conditions, whether it may be homogeneous, stratified, uniform, and non-uniform slopes. See, this method can be used for all type of soils and all the conditions. All the type of soils and all the conditions. So now, what we are going to do here, sir? Again, Again, if you look over here, so then what we are going to do is, let's draw the slope once again. So this is a slope. Now, as I told you, the slip surface will pass through the toe. The slip surface will pass through the toe like this with an arbitrary center O. And this is the radius R, and this is the angle theta. So now what we are going to do in this method here is, please observe. See, in this method, the failure wedge or the soil wedge is divided into slices, minimum 6 to maximum as 12. Soil wedge is divided into slices with a minimum of 6 to maximum of 12 slices. So slices means a small portions. So now what we are going to do is, one slice, two slice, 3, 4. So minimum of 5 to minimum of 6 slices and a maximum of 12 slices, and these slices would be uniform slices. So how many slices I have from 1, 2, 3, 4, 5, 6. Now what we take is, we take each and every slice outside. See, first of all, I am going to divide into slices. Now what I do is, let's take one slice outside. So let me take one slice outside and find out the weight of each and every slice. Now, see, my question for you, does this slice is exactly similar to the slice in the finite slope or not? So now you see, this is the weight W, and perpendicular to this means normal to the plane, there is a normal force, and along the plane there is a shear force. So now if you see, we are going to divide the slices into 6 parts, minimum of in reality it is not going to be possible to, in reality you are not going to the slope and you are not going to be cut rate. This is analysis, Baba. Okay, so now if you look over here, what happens is, so at first every slice, the weight is going to be resolved into 2 components, normal component and the tangential component. Now every slice, this is a normal component N1, normal component, normal component, normal component, normal, and normal. So if you observe, each and every normal component is trying to pass through whom? Center. Each and every normal component is trying to pass whom? Center. See, these are nothing but the normal components. Similarly, there are tangential components whatever, this is nothing but the tangential component. So every slice we take it out, and what we are going to do is we are going to resolve that into two components. Weight of each slice is resolved into two components, and normal component always pass through center. So, sir, what you have done over here is I simply make sure, now this is the key point over here. Weight of the each slice is going to be resolved into two components, and normal component is passing through the center. Arey Baba, if the force is passing through the point where the rotation should take place, is there any moment? Is there any moment? See, let's take this is a point, and this is a force. And what is the moment at this point? Is a force into perpendicular distance. Yes or no? But if the force is passing through the point, then where is the moment? There is no moment, which means earlier in this condition, I told weight is going to be responsible for the failure. I told weight is going to be responsible for the failure. So weight is here responsible for failure. And now let's come to this condition. What I am doing is, this weight is going to be resolved into components, normal component and shear component. Normal component is passing through the center. As a normal component is passing through the center, the normal component will not have any moment. But what about the shear component, sir? What about the tangential component? This is going to be T, right? And now you tell me, as it is going to be passing through the center, you see, this normal component always tries to pass through the center. Whatever the normal component you take, so this is going to be passing through the center, and this is nothing but radius r. So now who is responsible for the failure, sir? Tangential component is going to be responsible for the failure. As a normal component is going to be passing through the center, so who is responsible for the failure? Tangential components. Tangential component of weight T is responsible for failure. He is responsible for the failure. So now note down all tangential components T for all slices. For all the slices, we are going to find out the T value, and then now you tell me which is going to be responsible for the driving moment. MD is equals to, my dear students, you tell me, is the weight is going to be responsible? No. You see, here the rotation is going to be happen. Here the rotation is going to be happen. The soil wedge is going to be slides by means of tangential force. Now, what is the moment? Tangential force into perpendicular distance as R. Tangential force. So for one slice and for all the slices are sigma T into R. Sigma T into R. This is the only difference you please observe from the earlier one to this one. You please look here. What is the driving moment I took? Whatever the weight into perpendicular distance x. Here this is a weight and this is the perpendicular distance. And now in the case of the Swedish circle method, Weight is not actually responsible. Who is responsible? Tangential force is going to be responsible. As the tangential force is going to be responsible, then what is the moment of the tangential force with respect to center? Driving moment with respect to center. What is the driving moment? Sigma T into R. I hope you understood this point. Sigma T into R. So because who is responsible for over here? T is responsible for failure. So that's why the only change is the driving moment. And what about the resisting moment, sir? Resisting moment Mr is equals to resisting force into lever arm. And what is that lever arm? The lever arm is also going to be R. Come on. Now, this is going to be the resisting force and this is going to be the driving force. So here, this is driving force and this is resisting force. And the lever arm is going to be same over here, right? So now the factor of safety is equals to resisting force by driving moment, resisting moment by driving moment, Fr into R by sigma T into R. RR will get cancelled. What is the factor of safety? Resisting force by summation of all the tangential components. So what is this resisting force, sir? Shear strength into length of arc into 1. Shear strength into length of arc into 1. That's what, Nana. Look, when you cut the bottom of the slice, is going to be arc, sir. No, sir. While we are analyzing, we are going to take it as a horizontal, sir. Why? Because when you cut down slice, the curve is going to be very, very small. The curve is going to be very, very small. But while you're taking at the end, you have to take it as arc only. Don't worry about that. And one more thing is this method is different. Earlier method is different. For you assumed weight is responsible, but in the case of the Swedish, it got to know that the actual responsible is going to be tangential force. So now C plus sigma into tan phi into L bar. C into L bar plus, you please observe, what is the normal force? Normal force means normal stress first. So come on. So if I want to write, what is the normal force? Normal stress means normal force by area. Yes or no? Area. Which area? See, for every slice there is a normal force. Then what is the normal stress? Normal force by area. Area of this arc slice. And if I take a total normal forces, then what is the area? Area is going to be area of arc. Arc area. Then I can write that sigma n by length of arc into 1. So sigma into L bar into tan phi. So what is the factor of means resisting force is C into L bar plus what is sigma into L bar? Sigma n into tan phi. Sigma n into tan phi. So see, I took the same thing. Here you see, what is the more resisting moment I took? The same thing or not? Means resisting force. You see, this is nothing but the resisting force or not? Yes. What is the resisting force here? S into L bar. But in this case, I took the shear strength as a CU because that is suitable for only case. Now, after all the discussion, the factor of safety, is equals to, you know, that resisting force by tangential forces. The resisting force is nothing but C into L bar plus sigma into sigma n into tan phi by sigma t. Sigma n into tan phi by sigma t. For study CPACE, In the case of the steady C phase, you know that F is equals to C into C dash into L bar plus sigma N minus sigma U into tan phi by sigma T. Sir, why you have written this one? Have a look over here. This is a steady C phase only, right? What is the vertical? Sigma, and upward U. So then what is the normal stress? Sigma minus U. Yes, this is in terms of stresses. This is in terms of stresses. Now, if I ask you in terms of force, if I ask you in terms of force, if I ask you in terms of the force, for every slice, you take for every slice, there is a normal force, there is a tangential force, and there is a now U also. So in the case of the steady C phase, whenever the steady C phase comes into existence, there is a pore water pressure force also. So here, this is the final equations. In the case of the steady C phase, so there is a upward force known as the uplift pressure. If you have any doubt, you please go through the infinite slopes. In the infinite slopes also, I told you the same point. In the infinite slopes also, I told you the same point. There is a normal stress, there is a shear stress, and there is a pore water pressure stress. But now I am discussing about whom? Forces. Normal force, shear force, and pore water pressure force, where sigma N is total normal forces, sigma T total tangential forces, sigma U total neutral force, means pore pressure force, force due to pore water pressure. So this is about the factor of safety. See, my ultimate point is what I am writing over here, right? I will write a small thing over here. So my ultimate point is factor of safety. I will be erasing this later. Resisting moment by driving moment. Okay. So the resisting moment means resisting force into lever arm. Yes. So in the case of CU 5U0 analysis, weight is responsible for. So weight is responsible there. So driving moment is W into X. And in the case of the Swedish circle method, tangential force is responsible. So T into R. R will get cancelled. And what is resisting force? Shear strength into length of arc. In the case of 5U0 analysis, CU into L bar. But in the case of the, for all soils, you have to take CU into sigma into R. C plus sigma tan phi into L bar. So let's take this C inside. If you take C inside, then sigma into L bar into tan phi. In 5U0 analysis, we can take phi 0. If phi 0, then this is the resisting force, right? See, there is no confusion over here. The only point is, after all this one, okay, who is responsible for failure? In 5U0, weight is responsible. In Swedish circle method, tangential force is going to be responsible for the failure. Who is responsible for the strength? Shear strength, that's it. Yeah. Now, the note point is over here. Look, the note point is in Swedish circle method, whatever the slice you see, between the slices, between the slices, you see, whatever the side forces on slices are neglected in Swedish circle method, but considered in Bishop's method. So side forces on slices are neglected in the Swedish circle method. So what is mean by the side forces? You see, due to this slice and due to this slice, there must be some side forces acting on the slice 4. If this is a slice 4, then due to slice 5, due to slice 3, there must be some side forces. Those side forces have been neglected in the case of the Swedish circle method and considered in Bishop's method. Considered in the Bishop's method. And Swedish circle method is most commonly used method, gives factor of gives relevant factor of safety compared to Bishop's method. And Sorry, suddenly it went back up. Yes. So let's come over here once again. I'm sorry it was missed. So now you see here side forces on the soil slices are neglected in the Swedish circle method. So and moreover that all these methods are trial and error procedures. Look, all the methods are trial and error procedures. So what is the meaning of trial and error procedure? My dear, you see here I took one slip surface, right? What is this? This is nothing but a slip surface, okay? And then finally I got this factor of safety, okay? So for one slip surface, I got the factor of safety. Do you tell me exactly where the slip surface is going to be formed? Again, you see over here. So in this figure, the slip surface may form like this. The slip surface may form like this, or the slip surface may form like this. So this is going to be trial 1 and 2, and this is going to be 3. Look, while we are finding the factor of safety, we take a slip surface, and that slip surface is going to be passing through the toe. So this is a slip surface, you know that. And we are going to take it as a trial and error method because all the methods are trial and error methods. Why? Because we take a different slip surfaces. We take different slip surfaces. Mind it. We take a different slip surfaces. Tomorrow is a holiday. Tomorrow is a Sunday. So tomorrow is a holiday. So tomorrow I'm not going to take any class. So that's the reason why I'm taking 15 more minutes. Not it's not 1, it's 12:50. Now all the methods are trial and error methods. By assuming trial slip surfaces and whichever has minimum factor of safety, whichever has minimum factor of safety is taken as critical slip surface, which means and if that factor of safety is less than 1, slope is fail, and more than 1, slope is safe. So what we do is, look, for example, in phi u is equals to 0 degrees analysis. What is the factor of safety? Cu into L bar into R by W into X. You know, this is going to be slip surface, right? This is going to be slip surface. So for this slip surface, find the factor of safety F1. Find the factor of safety F1. Similarly, this is one more slip surface. Find the factor of safety F2. This is one more slip surface. Find the factor of safety F3. So out of these three, see, this is a phi u equals to 0 analysis. This is the factor of safety for all the trial slip surfaces. 1, 2, 3. You find out the factor of safety. Whichever has a minimum factor of safety is taken as a critical slip surface. So let's say, for example, F1 is 1.2, F2 is 3.5, and F3. F means a factor of safety. And this is going to be 2.1, which is a minimum. This is the minimum. And this minimum, F1 is going to be 1.2, which is more than 1 or not. Then slope is going to be safe. So what we are going to do is, we are going to find out the factor of safety. And once we find out the factor of safety, we take different slip surfaces. How many slip surfaces we have to take, sir? Minimum 3 to 5. Minimum 3 to 5. So that's the reason why I take 3 slip surfaces. I can find out the factor of safeties, and whichever the factor of safety is going to be minimum, that is going to be the critical slip surface. And that factor of safety, if it is greater than 1, then the slope is going to be safe. So that's there with these conditions. Gap between the two slip surfaces, it's up to you now. You take anywhere. There is no peculiar condition. This is a trial 1, trial 2, this is trial 3. It's up to you. But that point should pass us through the toe. That's it. This is a slip surface will pass us through the toe. Sir, why did you consider 5U0 analysis, sir? See, I said an example. You can do the same thing for the method of slices also. You can do the same thing for the method of slices also. So all the methods above are going to be useful. See, you can go for a method of slices, and you can go for the Swedish, that means you can go for Bishop's method. See, I am not going to discuss about the Bishop's method because that's going to be very, very large, and it is not at all important for the gauge. The only difference between the Swedish circle method and Bishop's method is side forces are considered. I am not going to discuss anything regarding to Bishop's method. So now let me solve some problems. Yes, add your friends over here. This is classroom practice question. Classroom practice question. You see, find the factor of safety with respect to shear strength and with respect to height along the inclined slip surface. See, now I'll be clearing all your doubts. Observe clearly. I don't want you to people to remember the formula. I want you to know whether it is a finite slope or infinite slope. Understand this concept clearly. Find the factor of safety with respect to shear strength. Okay. With respect to height along the indicating a sliding failure. AB. First of all, you need to know, is it finite slope or infinite slope? So this is rotation, right? As it is rotation, this is a finite slope. Okay, that's okay. This is a finite slope. And I have given you the shear strength parameters C, phi, and the gamma. C is 50, phi 10, and gamma is going to be 18. Okay. Normal effective pressure on the sliding surface. See, the normal effective pressure, which means these are C comma phi. If I don't mention C phi, if I say effective stress, then these are nothing but C dash phi dash, C dash phi dash. Okay. So given normal effective stress on AB is going to be 255 kilopascals. And the tangential disturbing force, you see, tangential disturbing force along AB is given as 840 kilonewtons. So tangential force along AB is going to be given as 840 kilonewtons. My dear, now I'll ask you question number one. Question number one. Is it a finite slope? Yes. And in the case of the finite slope, are we going to discuss about moments or not? Yes. Who is responsible for the failure here? Tangent. So tangential force is responsible for failure. Tangential force is responsible for the failure. Okay. What is factor of safety? Listen, I'm not going to use any formula directly. Think about that. I don't write the formula directly. I know who is responsible for failure? Tangential force. So what is the factor of safety in the case of finite slope? What is the factor of safety? You please tell me. Resisting moment by driving moment. Resisting moment by driving moment. Now, what is the resisting moment, sir? Resisting force. Fr into, you see, this is nothing but R, right? R by tangential force AB into R. R will gets cancelled. So the factor of safety is equals to, what is the resisting force? Shear strength into length of arc by tangential force along AB. And you know that shear strength is nothing but C plus sigma into tan phi. So C dash plus sigma dash into tan phi dash into L bar by tangential force as AB. As they given effective stress, then this is going to be C dash and this is going to be phi dash. C comma phi can be either CU or phi U, sorry, CU phi U or C dash phi dash. But I told you clearly which stress I am taking here, effective stress. So as it is effective stress, then these are going to be C dash and phi dash. My dear fellows, did I ask you to remember any formula here? No. What is the force that is causing the failure? Tangential force. What is the force that is resisting? Resisting force. I write that. What is the moment? Resisting force into perpendicular distance R by tangential force into perpendicular distance with respect to center. Everything is with respect to center. You have to take everything with respect to center. So now, what is the shear strength? C plus sigma into tan phi. So please substitute the values. I don't do anything much of this. I just find out these values. So what is C dash given? 50 plus 255 into tan phi dash. What is the phi dash? 10 degrees into L bar. We need to find out what is the length of arc. Please tell me. R theta into pi by 180 degrees. What is R value here? 10 into theta. 60 into pi by 180 degrees. Please find out the L bar value. Which is going to be 10.47 meters by 840. So find out the factor of safety, please. What is the factor of safety? I hope it is going to be 1.18. The factor of safety is going to be 1.1. I hope you understood now. So how come we say it's a finite slope, sir? After all this one, sir, if you ask this question, sir, then what is this? What is this? Is it a rotation failure or translation failure? This is a rotational failure. As it is a rotation failure, then you can say it as a finite slope, right? Yes or no? So now let's go with the next one. In this, there is a one more point. With respect to height also they are asking. So second one in this is factor of safety with respect to height. I told you factor of safety with respect to height is going to be HC by H. What is HC? Critical height. So HC is equals to 4C by gamma root Ka. So now in this case, what is phi value? 10 degrees. Or we can write 4C by gamma into tan alpha F. Alpha F means 45 plus 5 by 2. 45 means plus 5, 10 by 2, which is going to be 50 degrees. So HC is equals to 4 into given C value as 50 by gamma. What is gamma I have given? 18 into tan alpha F as a 50 degrees. So what is the critical height, please? What is the critical height? 4 into 50 into tan 50 by 18, which is going to be 13.24 meters. Now, coming to the height. You see, I have given you the figure in such a way, this point is going to be exactly vertical. So this is R. Now, what is the height of the slope? This is the height of the slope. What is the height of the slope? This is the height of the slope. So now you tell me this is going to be center O. And what is the radius I have given you? 10 meters. And what is this value? 60 degrees. Let's take this as X. And again, the total is going to be radius given as 10 meters. You please observe. What is the total I have given? 10. And you know, this is nothing but the height of slope or not. What is the height of slope? H. So I need to find out this H. In order to find out this H, now can I write cos 60 degrees is equals to, you take this triangle, cos 60 is equals to adjacent x by hypotenuse 10. Then x is equals to cos 60 1 by 2 into 10, which is going to be 5 meters. And you know that from figure, h plus x is equals to r, then h is equals to 10 minus 5, which is equals to 5 meters. Then what is the factor of safety with respect to height? HC by h. 13.24 meters by 5 meters. See, where h is the height of slope. So please find out this value. This is going to be 2.648. That is the factor of safety with respect to height. So final answers are going to be factor of safety with respect to shear strength. This is going to be 1.18. And factor of safety with respect to height is going to be 2.648. Some of the askings are, how come you know that tangential force is the responsible for failure? You see the term tangential disturbing force. Okay, fine. So tomorrow is a holiday. Tomorrow there is no class. I'm stopping. Please stop, sir. Please stop, sir. Ye kya re bhai? For just 3 hours of the concept itself, you are being the same way. Huh? What is the next subject? Array, some of the people I don't know. Some of the people are like, sir, when the subject will complete? When the subject will complete? Do you want the subject to be complete or do you want to learn the subject? Number one. And some of the students like, stop the class, stop the class, stop the class. If I stop the class, in later, you will be the one who will be in problem. See, the half of the day for you is for the studying purpose. Okay. So after this class, I don't think you have much, means you might be attending your college classes also. And I know, and you know it very well, how much percentage you attend in the classroom classes. You just attend for the sake of the attendance only. I know that. And you also know that. So probably, and most importantly for the final years, if somebody is a final years, and you know it much more, and for the third years, for the sake of the academics and for the sake of the placements, so you are going to attend for the class, means your college timings also. But the subject I am teaching you, if you say hardly whatever the discussion I made is infinite slope and finite slope 2 methods, there is no much formulas also. So don't bang your heads. This is last slide, please. Sir, how you taken this PC as C dash, sir? Because they have given the effective stress, na? So effective stress means drained analysis. I can take it as a C dash. No, this chapter has not completed yet. Yes. So now it's already 1:15 hours. You please go through the notes. And one more thing, students. After our sessions ended, there will be one day fully for the sake of that doubt clearing session. So one full day, like some 4 to 5 hours, or like that, up to 2 or 3 o'clock, are same timings, like 9 to 1:30. So there will be a doubt clearing session. So whatever the doubts you are having from chapter number 1 to chapter number 2, we are going to discuss all those things. And for today, I'm going to conclude the session. I'm not going to take any doubt clearing session today also. So now please go through the class and I'll be sending you the class notes as soon as possible. Okay. I hope you people are able to understand the class and able to solve the questions also. You please go through the notes once again, then we'll be seeing. Tomorrow is a holiday and we'll be meeting again on Monday. Fine. Bye.